Okay, so the topic for today is absolute value equations. And we're going to start with probably the easiest absolute value equation, which is the absolute value of x equals some number, we'll say 6. And the idea is we want to find the values of x that make this statement true. Well, just using a little bit of logic here, we can say that x is definitely going to equal 6, but x could also equal negative 6. And if we do a quick check on that, we can see that the absolute value of 6 equals 6, and similarly the absolute value of negative 6 equals 6. Now, on the other hand, if I had the absolute value of x to equal negative 6, again, using logic, I got to find all the values of x that are going to make this statement true. Well, if I say x equals 6, when I plug that in, not a true statement. And if I say, okay, well, let's let x equal negative 6, and I go to plug that in, not a true statement. So in this case, we can say no solution, because there's no value of x that's going to make an absolute value turn into a negative number. All right, so if we build on our first equation, and let's now go with the absolute value of x plus 3 equals 6. Using the same type of reasoning, inside this absolute value, I'm allowed to have the number 6. So I'll put that. But I'm also allowed to have a negative 6. And so when I solve this for x, here I get x equals 3, and here I get x equals negative 9. Now let's just see if this makes any sense. When I go to do the check, I can say 3 plus 3. I want to know if the absolute value of that equals 6. Well, that's a true statement. Or when I plug in negative 9 here, negative 9 plus 3, that's where I get the absolute value of negative 6, which is also 6. So both of these solutions work. All right, building off of that, let's say that I put a 2 out in front. And when I go to solve this thing for x, well, before I do anything, I want to make sure I get this absolute value isolated. I want to get it by itself. We are not going to distribute the 2. Instead, what we're going to do is divide both sides by 2 because of the inverse operations. I'll explain a little bit later why we don't distribute the 2. But now this gives me the absolute value of x plus 3 equal 3. And I play the game again. What legally can go inside the absolute value here that's going to allow an answer of 3? Well, the first thing I can put in there is a 3. And the second thing that I can put inside the absolute value is a negative 3. So I'm solving both of these. Here I get x equals 0. And here I get x equals negative 6. And if you're not convinced that that's the answer, all you have to do is plug it back in. We're just going to do the check. So when I plug 0 back in for x, 2 times the absolute value of 0 plus 3, I want that to equal 6. So that's 2 times the absolute value of 3, which is 2 times 3. And I got myself a true statement. If I'm going to check negative 6, I'm going to plug negative 6 in for x. 2 times negative 6 plus 3, absolute value. 2 times the absolute value of negative 3. This gives me 3. And in fact, that one works as well. So I can say that both of these answers, 0 and negative 6, work. Okay, building off of that. Building off of that one, if I have 2 times the absolute value of x plus 3 plus 4 equals 6. I want to get this absolute value by itself. That's the key. Isolate the absolute value. One step at a time. subtract a 4. Gives me a 2 there. Then I'm going to divide everything by 2. We are not going to distribute the 2. I haven't told you why yet, but I'll show you one in a second why we don't distribute the 2. X plus 3 equals 1, and it's time to play the game. What legally can go inside the absolute value? Well, I could put a 1 in there, or I could put a negative 1. Both of those are going to work. So I can say x plus 3 equals 1, or x plus 3 equals negative 1. Solve. That gives me negative 2. And that gives me negative 4. Again, if you're not convinced, if you don't believe in the algebra, go plug it back in and you'll see that it in fact works. All right, so why don't we distribute? We're going to have a general rule of not to distribute over an absolute value. And the reason goes something like this. If I have the absolute value of negative 2 times x plus 3 equals, let's call it 6. Technically speaking, when I divide both sides by a negative 2 here, which is what we want you to do, because we do not want to distribute, when I divide by a negative 2, I get the absolute value of x plus 3 to equal a negative number. And we said earlier on in the recording here that that can't be possible. There's no number that I can put into this absolute value that's going to cause an answer of negative 3. However, if I were to distribute, if I treat that absolute value as a set of parentheses, and I distribute that through, that gives me negative 2x minus 6 to equal 6, and now I'm led to believe that there is an answer here. I'm led to believe that negative 2x minus 6 would equal 6, and negative 2x minus 6 would equal negative 6, and I can go on to get a solution, but we're going to call that an extraneous solution. Meaning that algebraically it worked out, but when you go to plug it back in, it really doesn't work. So we just have this general rule, and we say don't distribute over the absolute value so that you don't get yourself into this situation. That's it for now. Let me know if you have any questions.